All right, in this video, we're going to introduce absolute value equations. We're going to solve absolute value equations in this video and the next video, and then we'll look at absolute value inequalities in the video after. So the absolute value of a number, for instance, the absolute value of a number b, denoted that number surrounded by these absolute value bars, represents the distance that b is from 0 on a number line. So you may have been told in prior math courses that when you find the absolute value of a number, you just ignore the sign, and whatever that number is what you get. So for instance, the absolute value of 5 is 5, because 5 is 5 spaces away from 0. But the absolute value of negative 5 is also 5, because negative 5 is also 5 spaces away from 0. So it doesn't matter what direction you have to head to get to 0 on a number line. What matters is how many steps you take. So an absolute value equation is one in which our variable is inside of an absolute value expression. So we have, for absolute value of x equals 2, we actually get two possible values for x. We get 2 and we get negative 2, because the absolute value of 2 is 2 and the absolute value of negative 2 is 2. Both of these values, 2 and negative 2, are 2 spaces away from 0 on a number line. One of them just happens to be on the left. The other one just happens to be on the right, but they're the same distance from 0, which is why the absolute value of 2 and the absolute value of negative 2 are the same answers. So in solving absolute value equations, we want to get our absolute value bars by themselves if we have to. And for something like the absolute value of x equals c, means that x could equal c, or x could equal the opposite of that, negative c. So for instance, the absolute value of x equals 2 means x could equal the 2, or x could equal negative 2, the opposite of that. So make sure again that your absolute value bars are isolated on one side before you separate them into two separate equations. So example 1, we're going to solve each. We have the absolute value of 2x minus 3 equals 11. So the number one mistake I've seen students make with absolute value equations is they just drop the absolute value bars and solve 2x minus 3 equals 11. And while yes, that is true, the absolute value of 11 has to equal 11. So 2x minus 3, this inside the absolute value bars would have to equal 11. There's also the case where what's inside the absolute value bars equals negative 11. So either 2x minus 3 equals 11 or 2x minus 3 equals negative 11. And if we add 3 to both sides in each equation, we get 2x equals 14 for our first. And for our second equation, we get 2x equals negative 8. And we get x equals 7 and also x equals negative 4. Now again, we can check each one of these by substituting our value of x into the original equation and see if the left and right sides come out to be equal. So we have 2 times 7 minus 3 is 11. The absolute value of 11 is 11. 2 times negative 4 minus 3 is negative 11. The absolute value of negative 11 is 11. We also, reminder, have the ability to graph the left and right sides and find the intersection points for them. So we'll just have to zoom out a little bit. Can also move the graph around. So let's look at the intersection points. We have negative 4, 11 and 7, 11, where again the x coordinates negative 4 and 7 represent the solutions to our equations. So negative 4 and 7 are the solutions to our equations. Part B, we have the absolute value of 3x minus 1 equals 5. So we either have 3x minus 1 equals 5, or maybe 3x minus 1 equals negative 5, because again, the absolute value of 5 could equal 5, but also the absolute value of negative 5 could equal 5. So what's inside those absolute value bars, the 3x minus 1, have to either equal 5 or negative 5. So adding 1 to both sides in each equation, we get 3x equals 6. Here we get 3x equals negative 4. Divide both sides by 3, we get x is 2, and we get x is negative 4/3. Now again, we could check those algebraically. We could also check them graphically. So if we hide this one, if we graph each of these, notice that, and I'll just zoom in so it's easier to see. Notice that we have negative 1.333, that's a decimal approximation for negative 4/3, and we have 2, so x equals 2 or x equals negative 4/3 are correct, because again, those are the x coordinates of the intersection points. All right, that about does it for this video. Thanks for watching, and I'll see you next time.